Hello everyone, today we are going to continue to talk about the unit circle, specifically how we finally use this thing. So last week we talked a lot about how do we get all of these pieces in the unit circle, and now we're going to focus on what does that actually help us do. So before we get into this, it is going to be important that you have a complete unit circle. So if you have not put all of your radians, degrees, and coordinates all into one unit circle, I would suggest that you do that. So that's my version here that I have. So we can reference this. If you haven't done this, you can either pause the video right now and copy all of this, or you can go back and watch the videos from last week and get these all put together. Okay. Now let's start to talk about how we can use the unit circle. So just a couple things. We have the fact that our radius here is 1. So remember, out to all of these coordinates, the distance from the center is 1. That's going to be important as we start to look at these. So I'm going to use my triangles that we used on the original unit circle. Now this is a slightly different version, so they don't fit in here perfectly, but you at least can kind of get the idea of what we're talking about. When we go to 30 degrees, I'm using this triangle. It should technically be out here, but you get the idea. So with this one, let's actually start talking about cosine. If I've tried to find cosine in this triangle, what I would do is cosine from SOHCAHTOA tells me that it's adjacent over hypotenuse. Well, adjacent is now this side that's along the bottom. That's the square root of 3 over 2. And my hypotenuse is 1. Well, we know that anything over 1 is just itself. So really my answer is the square root of 3 over 2. Okay, so what I'm seeing here is that my cosine is this piece along the bottom. Let's see if that holds for other triangles. I'm going to lay this right on top of here. This is my 45, 45, 90 triangle. Again, I would do my adjacent, which is the square root of 2 over 2, over 1, which stays as the square root of 2 over 2. And you can even see right now, I'm still talking about this bottom edge, which is my horizontal component of this point. It's the x coordinate. Okay, let's try one more with 60 degrees. And I can actually check that one as well. Again, as my distance along the bottom, it's going to be my adjacent side 1/2 divided by 1, which is 1/2. So what I'm seeing here is that all of these x coordinates, or my distance along the bottom here, is what's determining my cosine factor. So when I go over to my notes page here, for cosine, I'm going to say that this is my x coordinate. Okay, so when we're using the unit circle, cosine is always given by the x coordinate. Now that goes for all of our other coordinates that are here as well. If I ask you for cosine of 180, I take the x coordinate, that's going to be my answer. Okay, and so we'll kind of work through some of those examples here in a minute. Let's talk about sine though. We go back to my 30-degree angle here. Okay, sine is opposite over hypotenuse. Well, now my opposite side is the 1/2, my vertical piece, over 1. Over 1 again is just going to keep it the same. So it's going to be 1/2. Okay, and if you start to look at what's happening here, I'm now talking about my vertical piece, and as I go to my other triangles here, you're going to see that it's my vertical piece again is my opposite side, and then again with my 60, my opposite side is again the vertical piece. They're all going to be over 1, so they all just stay as these values that are here as my vertical pieces. Now my vertical piece we use to give our y coordinate. So all of our y coordinates show up as sine. Okay, now I might have went through that one a little quick, so if you need to go back and rewatch that one, you might need to. But the point is that we're just using those coordinates for sine and cosine. So if it's helpful, you can think of our coordinates on our unit circle as the cosine value, comma the sine value. Okay, so you can think of it that way. So as I go around my circle, all of my x's are cosines and all of my y's are sines. Now, that's nice that that works out perfect for us because I have 2 coordinates, so I get my first 2 trig functions. The problem is we actually have a third trig function as well. We have tangent. Okay, now tangent's a little bit trickier. So let me go to just my 30-degree triangle here for a second. Okay, if I look here, tangent would be opposite over adjacent. Now when I do that, I end up with 1/2 over the square root of 3 over 2. So I'm going to go to the bottom of my page here a second, and I'm going to write this as tangent of 30. And we're going to try and simplify through this a little bit. So I said that was opposite, which is 1/2, divided by adjacent, which is the square root of 3 over 2. Okay, now first of all, I'm dividing both of these by 2. So these dividing by 2's actually cancel. This is the same thing as 1 over the square root of 3. Okay, now through all of this trig stuff, we do not like our square roots in the bottom of fractions, so we're going to get it out of there. We're going to multiply by the square root of 3 on top and bottom. Which is going to end up canceling. We get a square root of 3 on top. Square root of 3 times the square root of 3 is the same thing as the square root of 3 squared. And the square and square root cancel. And I'm left with the square root of 3 over 3. So what I'm going to do here is I'm going to label this at 30 here. I'm going to say that my tangent is equal to the square root of 3 over 3. Okay, now let's go to our 45. Okay, for my 45, my opposite side is going to be my square root of 2 over 2. My adjacent side is the square root of 2 over 2. So what happens at 45, and again I'm going to do this at the bottom of the page here, I end up with the square root of 2 over 2 divided by the square root of 2 over 2. Well, in that case, everything is the same on top and bottom, so it's a very simple 1. So my tangent here at 45 is going to simply equal 1. Okay, and then my final piece, my 60-degree triangle, okay, my opposite is the square root of 3 over 2. My adjacent is the 1/2. So for tangent of 60 degrees, I'm going to have the square root of 3 over 2 divided by 1 over 2. Again, my 2's drop out, so I end up with square root of 3 over 1. Anything over 1 is just itself. So just the square root of 3. So 30 is the only one we have to rationalize. The other ones just kind of work out. Now, what we need to figure out is how do those patterns relate to what we already know? Well, if I look at all of these triangles, and I'm not going to put them all in the right place, but you can start to see them all here now, and I look at my work down here at the bottom, what I'm doing for tangent is always the opposite over the adjacent. And so for all of these triangles, when they're set up in the middle there, the opposite side is the y-coordinate, the adjacent side is the x-coordinate. So really what I'm doing here for my tangent is my y divided by x. Now I actually want to think of that slightly differently because we know that the y-coordinate is the same as sine and the x-coordinate is the same as cosine. So this is the same thing as sine divided by cosine for that value, whatever value I'm at on my circle. Now that's going to be important because that allows us to find tangents at other places as well. And so I've only labeled the tangents in my first quadrant here, but just like all of my coordinates, they go straight across and straight down just like everything else. Okay, but we have to worry about positives and negatives. So what we know is we're dividing our two coordinates. So if I divide a positive by a positive, tangent is going to still be positive. Okay, now if I go across into quadrant 2, so either at 120, 135, or 150, I'm going to have a positive divided by a negative. Remember, it's always y divided by x. Well, if we divide by a negative, I get that the tangent is going to be negative. Okay, if I go into quadrant 3, now I'm down here 210, 225, and 240. Now I'm taking a negative divided by a negative. Well, that one's probably the trickiest one. That actually turns back into a positive. Okay, and then finally over here, for 300, 315, and 330, we are dividing a negative by a positive, which is going to give us the tangent being negative. Okay, so that gives us our sign. And then I can, again, kind of take these all the way through. So I'm not going to draw in those lines that we put in last week. I just want to think of going straight across and straight down. If I need to get to like 225, I would go up and over. I would see I'm at 45, so my tangent is going to be 1, and I know that it's going to be a positive, so it's a positive 1. If I was up here at 135, it would have been a negative 1. Okay, and we'll do some practice with those here in a second as well. I do want to talk about our 4 main points though here as well, because this can get a little bit confusing for tangents as well. So if I look at tangent of 0 here, at 0, or 360 or 2 pi if I go all the way around. If I'm at this point over here on the side, my tangent is going to be my y-coordinate divided by my x-coordinate, just like I said here in our notes. So I'm going to take my y-coordinate, which is 0, and divide it by 1. Well, 0 divided by 1, 0 divided by anything, is always 0. So my tangent there is going to be 0. That's going to be the same thing over on the other side here at 180 and pi, because it's 0 divided by negative 1, it's still 0. So that one goes straight across as well. If I go up top here, okay, this is probably the trickiest one. My y-coordinate is 1, my x-coordinate is 0. So when I do tangent here, I end up getting, I'm going to write this one out, it's 1 divided by 0. Well, anything divided by 0 we cannot do, and in math we call that undefined. So we say that the slope there, or the tangent value, is undefined. And if you remember back, I just said slope there. We had undefined slopes when we talked about lines, specifically vertical lines. So what you can start to see here is I have a vertical line that goes through that point. So what you might start to figure out is from these triangles, your tangent value is your y divided by your x, or your sine divided by your cosine, but that's also your rise divided by your run. It's the slope of the line that connects from the origin out to this point. Okay, now it's hard to calculate that slope without knowing all this other stuff, so we just simply base it on what we know here. Okay, but it is really represented by that slope. Okay, so those are the tangent values. Those are kind of the ones that we're going to use. Now what I want to do is I'm going to shift this back over here. We're going to start to do some practice problems using our unit circle. So I am asked to find the exact value of the following. The exact value is really important because that means I can't go to my calculator. Okay, very easily I could go in and type in all these values, but I'm not going to get exact answers. I'm going to get rounded decimals, and that's not okay. Okay, we need to have the exact answers that come from our unit circle. So let's go ahead and use them. Number one, cosine of 0. Well, cosine, if I go up top, here's your x-coordinate. 0 degrees tells me I go over here to 0 degrees. So at 0 degrees, my x-coordinate is 1, which means cosine of 0 must be 1. And if you want to, you can double check that one on your calculator. It will just be 1. Okay, let's try sine of 120. For sine of 120, I take and go to 120, and I know that sine, if I move it down here just a second, is your y-coordinate. So now I'm looking at my y-coordinate here, 120. That's the square root of 3 over 2. So that is my answer. Cosine of 225, I go down to 225. Cosine is my x-coordinate, so this is a negative square root of 2 over 2. So that is my x-coordinate here. Then I'm going to try some radians. Okay, just going from degrees to radians, really the only thing is I just have to look for a different value as I try and find my place on the circle. I still need to find that place. So pi over 2, if I look, pi over 2 is up here at the top. So I'm using these coordinates, 0 and 1, and I'm talking cosine, so I use the x-coordinate, which is 0. So cosine of pi over 2 is 0. So the number that's next to our trig value there is really just telling us where on the circle we need to go, and then the trig value, trig function, the sine, cosine, or tangent, tells us with that coordinate then what do we need to do. Okay, sine of 5 pi over 3. Well, 5 pi over 3 is down here. Okay, I'm down here where my pen is. Okay, and sine is my y-coordinate, so I'm looking over here. That is a negative square root of 3 over 2. Then I have tangents. Tangent of 45. Go up here to 45. Tangent, we just said, was 1. We actually calculated that one out. And we have our work down here at the bottom of that one. What about tangent of 360? Well, 360 is all the way around, but I'm still over here at this point, and we just said, well, tangent is 0. So we're going to go with 0. All right, next one's tangent of 60. If I go up here for tangent at 60, that's the square root of 3. And then finally, tangent of 5 pi over 6. Okay, now this one's going to be a little bit trickier. I need to find 5 pi over 6. It's over here. It's the same as 150 if you want to use that value. Okay, so we're over here at this coordinate. Now I didn't label my tangent over here, okay, and that's on purpose. We're going to try and use what we already labeled over here in quadrant 1 to do this. So from 150, if I go straight across, I end up at this 30 degree. So my tangent is going to be the square root of 3 over 3. But what I have to figure out is it positive or is it negative? Well, that's what I labeled in the middle here. I labeled that my tangent needs to be negative. So this tangent needs to be the negative square root of 3 over 3, and that will be my final answer. Okay, the thing I really want you to notice here is that there's only so many answers that you can give. Okay, all of your answers are going to typically be either a 1/2, a square root of 2 over 2, a square root of 3 over 2. Those are all your sines and cosines, other than zeros and ones. You got those as well. Okay, and then for tangents, you're either going to have square root of 3 over 3, 1 square root of 3, or a 0 or an undefined. Okay, that's really it. I mean, you have positives and negatives in there as well, but I shouldn't be seeing answers of decimals or a 5 or a 6 or a 7. There's only so many answers that you can give. Okay, so make sure you're giving those answers, even if you're not quite sure what you're doing. Start to give things that are from the unit circle. If you're making up random numbers that aren't out of the circle, probably not going to be right. All right, let's move on to number 10, though. Number 10 wants us to identify whether the following values are positive, negative, or 0. I want to find tangent of 219. This can be a little bit tricky because 219, if I look here, is not a part of my circle. It's not one of the values that I labeled. But I do know I have 210 and 225. So 219 is going to sit somewhere in my circle down here. Okay? The important thing is this question did not ask me what the value is. It simply asked me whether it's positive, negative, or 0. So if I'm at a point somewhere down here in the bottom left of my circle, the question is the tangent value positive or negative? Well, if I look at what I labeled in the middle here, I said that tangent is positive. So I know that tangent of 219 is going to be some positive value. Don't know exactly what it is, but I do know that it's going to be positive. I should write that out, positive. Okay, we can also do the same thing sine of 100. Again, it's not exactly on my circle, but I have 90 and 120. I know it's going to be somewhere right in here. But if I look, sine is my y-coordinate. Move it down here. So my y-coordinate. So if I look at my y-coordinate in this upper left quadrant, quadrant 2, it is a positive value. So I know that sine of 100 is going to be positive. Okay. Finally, cosine of 238 is going to be down here almost to 240, not quite there. Cosine is your x-coordinate, so I'm looking at my x-coordinate there is negative. Okay, and this one is going to be negative. Okay. So there is my answers. Okay, now, last thing you could have here, you could have 0 as well. That's a possibility. That's really only going to show up at these 4 main quadrants, and only when I have those other coordinates that are exactly 0. I guess it could be tangents here as well. Okay, but if you're not at one of those main coordinates, you're not going to have the 0. Okay, let's talk about 11 and 12. 11 and 12 are kind of backwards questions, is the way I want you to think of them. I'm asking you for 2 values of theta such that tangent of theta is equal to 1. So I'm asking you for 2 different angle measures where the tangent is 1. So what I'm going to do is I'm going to start to look at my tangent values. I definitely have a tangent value here, which is at either 45 or pi over 4. And I didn't specify how to give your answers here. You can either give them in degrees or radians. My guess is most of you will probably go degrees. So we'll do 45 degrees, although if you wanted to, you could call this pi over 4. Okay, so that's 1 point. Now I need to find another place where my tangent is 1. Well, I know there's actually 4 places on this circle where it's 1 or some version of 1. Okay, I have at 45, I can go across, I can go down, and I can go back across again. But the important thing is this is a positive one, so I want the other place where it's positive. Well, if I look at tangents, tangents are also positive down here in the bottom left, which means if I go over and down, I'm at 225. That's going to be my other value, so 225 degrees, which is the same as 5 pi over 4. Okay, then we're going to do number 12. We have 2 values of theta such that cosine of theta is the negative square root of 3 over 2. I know it's kind of blurry on your screen right now, but this is the square root of 3 over 2. So I need to look at my circle where I have a negative square root of 3 over 2 in my cosine place. Well, cosine, if I go back up to the top here, is my x-coordinate. So I'm looking for where my x's are a negative square root of 3 over 2. Well, my x's are negative in quadrants 2 and 3. So I'm definitely looking here. And I have that negative square root of 3 over 2 at this point and down here at this point. So I can give my answer again either in degrees or radians as long as it doesn't tell me. Sometimes I will tell you what I want it in. Okay, so this is either 150 or 210 if I talk about degrees. Or you could also say this is 5 pi over 6 in radians or 7 pi over 6 in radians. Okay, so these are your 2 options as far as answers. Either give it to me both as degrees or both as radians. Don't try and mix the 2, otherwise you'll end up getting things wrong there as well. Okay, so that's going to be it for our video as far as using the unit circle. Next time out, we're going to talk about how we expand the circle beyond what we have here and start to talk about some negative angles and angles that are bigger than 360 or 2 pi.